What if you went to sleep and woke up to 100 AI research experiments? That's auto-research. Andrej Karpathy's new project, 42,000 stars, lets an AI agent autonomously run ML experiments on your GPU overnight. Write your research strategy in a Markdown file. The agent reads it, edits the training code, runs a 5-minute experiment, checks if validation loss improved, keeps or discards the change, and loops. 12 experiments per hour, 100 by morning. You program the research organization. The AI does the science, link in description. The conceptual shift in auto-research is worth sitting with for a moment. Traditional ML research looks like this. A human researcher forms a hypothesis, writes code to test it, runs the experiment, reads the result, and decides what to try next. It's slow. It's bottlenecked by how fast a human can read, think, and type. Auto-research inverts that. The human writes program.md, a Markdown file describing the research strategy, what kinds of changes to explore, what to avoid, how to evaluate results. Then the AI executes that strategy as fast as the GPU allows. You're no longer the researcher doing experiments. You're the research manager who wrote the methodology. Karpathy's framing in the README is deliberately satirical. He calls this the origin story of fully autonomous AI research. Written as lore from the year 10205, the technical design is deliberately minimal. 2 files matter. First, prepare.py, fixed constants, one-time data prep, the data loader, and evaluation logic. You never touch this. Second, train.py, the full GPT model, the Muon plus AtomW optimizer, and the training loop. This is the only file the agent is allowed to edit. The agent gets one instruction: improve the validation bits per byte score on the held-out dataset. The 5-minute training budget is fixed. So whether the agent tries a tiny attention tweak or a complete architecture change, the runs are directly comparable. The agent checks if val BPB improved. If yes, the change sticks. If no, it reverts. Then it reads the log of all previous experiments, updates its strategy, and tries again. The choice of validation bits per byte as the single evaluation metric is one of the most important design decisions in auto-research. Bits per byte measures how many bits the model needs to encode each byte of text on average. It's a measure of compression quality and fundamentally equivalent to perplexity, but normalized by vocabulary size. This matters because the agent might try changing the tokenizer, the model size, the attention mechanism, or the optimizer schedule. If you used cross-entropy loss directly, a vocabulary change would make runs incomparable. Val BPB doesn't care about vocabulary size. It's a fair playing field for any architectural change the agent might attempt. And lower is always unambiguously better. One number, one goal. The agent always knows exactly what it's optimizing for. The morning after experience is where auto-research gets genuinely exciting. The repo includes an analysis Jupyter notebook that lets you visualize the full overnight run. Every experiment, every val BPB score, every change the agent made and whether it was kept or discarded. You can see exactly which modifications improved the model and trace the agent's reasoning across 100 iterations. Did it find that wider attention improved things? Did it discover a learning rate schedule that the literature hasn't caught up with yet? The agent builds on wins cumulatively, so by experiment 80 or 90, you're often looking at a model meaningfully better than where you started, the product of automated compound improvements that would have taken a human weeks to run manually. Auto-research is a working prototype of something the field has been theorizing about for years: AI systems that meaningfully advance AI research without constant human supervision. It's small scale, a single GPU, a nanochat scale model, a bounded search space. But the pattern is real. Write the strategy in Markdown. Let the agent run the experiments. Review the results. Update the strategy. The human is now one abstraction level higher than before. Karpathy built this in about 2 weeks, and it immediately hit 42,000 stars, because everyone who saw it recognized the same thing. This is the shape of what AI-accelerated science looks like. Fork it, write your own program.md, and let it run tonight. Link in the description.